Hi guys, here's your flip lesson for today. It's a real quick one. I'm going to just do a couple problems and then I'm going to leave the rest of them for you to do. So it's just quick on my end. It's an actual review of average rate of change. So it is a standard that is carried through in every curriculum. So you've seen it in geometry and you've seen it in Algebra 1. So that's why it's going to be really a quick review for you today. Average rate of change, you have seen in y equals mx plus b, the linear equation, it's called the slope, right? Now, in the linear equation, it's called the slope because it's a constant rate of change. All right, now you can do or have average rate of change in other functions where it's not a constant. Functions that don't have a constant rate of change. So we're not going to call it slope. The only time you call it slope is when the rate of change is constant. We're always going to refer to it as average rate of change. And the formula for that is when you're given 2 points, it's the change in y over the change in x. Given 2 points, x1, y1, and x2, y2. And sometimes you'll see it like this. It's change in y over change in x, that little symbol. Okay, so you should be able to calculate the average rate of change between 2 points using either a table, a graph, or an equation. All right, so here's the first example. We're going to talk about in terms of a table. Joelle has a credit card that has a 19.2% annual interest rate compounded monthly. She owes a total balance B of dollars after M months. Assuming she makes no payments on her account, the table below illustrates the balance she owes after M months. So M is my X and B for balance is my Y. Okay, now it says determine the average rate of change from month 10 to month 60. So what I'm going to do is I'm going to come here and I'm going to grab those points when M is 10 and when M is 60. And real quick, I'm going to say, all right, that's my point. We're going to call it X1 and Y1. And this is my other point called X2 and Y2. And then we're going to plug it into the formula. The X2 and Y2. Y2 minus Y1 over X2 minus X1. So I'm going to do 2591.90 minus 1172, 60 minus 10. If you're putting this in your calculator all at once, make sure that you use the fraction button. And if you're not sure what that is, we'll talk about it tomorrow. I'm going to review it tomorrow real quick. But you're going to subtract the numerators numbers, and you're going to subtract the denominator numbers, and then you're going to divide. And it's 28.398. Now, what does this mean? It means from month 10 to 60, the balance average change was $28.398, $28 and roughly 40 cents per month. Now we have to be, when they ask you to describe, you have to be really specific with that. You have to state that it's from month 10 to 60. You can't just say the average rate of change is 28.39. You can't do that. It has to be from month 10 to month 60, because that's the only time period that we were referring to in this problem. Okay? All right, so I'm going to let you do B, and I'm going to let you do C. So you're going to do that, and then you're going to show me tomorrow when you walk in the door. I'm going to make sure that you have done this. You better have it filled out, please. Go to the next page, and we're going to do the graph. Okay, that was the table. Now we're going to do the graph. The diagram below shows the height y of a ball after x seconds. Find the average rate of change based on the given interval and explain its meaning in the context of the problem. Okay, so that means I'm going to take A. I'm going to do A. And this means I got to find when x is 0, because it's seconds. X is 0. So when x is 0, I'm going to look at that point there. So when x is 4, and look at that point there. Now, be careful of the intervals of the graph. This goes up by 2 at a time. So that is going to be, this first point right here is going to be 0, 14, because it's in between 12 and 16. And then when x is 4, I'm going to come here, and this is 422. Okay, I'm going to call this x1 and y1, x2 and y2. It's point 1 and point 2. I'm going to plug it in. Now notice what we're doing here. We're talking about change in y over change in x. Let's clarify this a little bit more now. The change in y, the y is feet over seconds, time. Okay, that's going to help us in our explanation if you write it like that, by the way. Okay, so now I'm going to say 22 minus 14. I'm plugging in the numbers now. 4 minus 0. And 22 minus 14 is 8. 4 minus 0 is 4. H over 4 is 2. Now what that means is it's 2 over 1, basically. So it's 2 feet per 1 second. That's what that means. And I noticed that's why I did it up here. I defined it. Is your y is your feet, your x is your seconds. So then when I go to describe, because it says and explain its meaning in the context of the problem, you must use some words. You would say, I'm running out of room here, so I'm going to use it down here. From 0 to 4 seconds, the ball will increase, because it's a plus, it's not a negative, increase by 2 feet every 1 second. Okay? So that is for that problem. You're going to do B. And if you look at like the actual graph, if you come up here and look at the graph, it would increase, right? I mean, there is a little bit of a decrease, but overall it is increasing. So if overall that interval from 0 to 4 is increasing, then we know that our rate of change should be a positive. If it's decreasing, going down the hill, if you're looking at it from left to right, going down that hill, it would be decreasing, would be a negative rate of change. Okay? All right, kids, let's go down to the next one. You're going to do B and C. You are in charge of filling in the rest. And again, I'm going to check tomorrow. Okay, last one, equations. If I give it to you in an equation form and you have to find the average rate of change, this is super easy. You just go to your calculator. Plug this into y1, and then you're going to go to the table and find the points. I want to do B because I want to make sure that you understand what that is. That's an interval notation. This is interval notation, kind of like when we did the domain and range of our graphs the other day. This is an interval notation, and these are intervals of x's. Those are x's. So they're saying, I want to know the rate of change from when x is 1 to when x is 3. Okay? So I would go to y1 and I would plug in 3x squared minus 2x plus 4. And I would go to the table, and when x is 1, if I put it in my calculator correctly, when x is 1, y is 5. When x is 3, y is 25. And then you would do your rate of change formula. And I am leaving it up to you to finish. Okay? So that's what it looks, that's how you're going to read that if it's in the brackets. All right. If for A, again, these are x's, so this is when x is -5, find y. When x is -3, find y, and use your rate of change formula. This whole thing, front and back page of what you have in your notes, should be filled out when you walk in. I'm done. I'm out. See you tomorrow.